Okay, it is 2 o'clock, so we will get started. Let me actually share my screen. Find the right screen here. Is everyone seeing the
You spotlight.
it of course disappeared for me. Oh, here we go. Okay. Everyone seeing the background that says Academic Library Makerspaces? Okay, anyway, it'll only be there for a minute. So welcome. Uh, this is Track D, Academic Library Makerspaces. We've got 3 amazing lightning talks for you. We're going to go ahead and get started right away. Well, we still have, let's see. Okay, good. Yeah, everyone's in the same room here. Okay, so welcome everyone. We will get started right away because we have 3 amazing lightning talks that we'd like to get through today and have time for questions afterwards. So our first lightning talk will be Dean Walton, who will be presenting why the right workshop matters. So I will go ahead and spotlight Dean so that everyone can see Dean, and I will stop my sharing so that Dean can share his slides, and we'll go ahead and get started.
Okay, well, it's a pleasure being here today. And I am going to be an old white guy talking about electronics. However, that said, I do want to say that I have managed or faculty advisor for an all-women student ham radio club and a robotics and rocketry club that was driven by another female student. Because there's a lot of women who want to learn electronics. And so that has been sort of my goal. A lot of our patrons are coming from computer science and physics. I'm at the University of Oregon, and we have an incredible craft center right next door to where I am. We also have another music and podcasting lab in another building. So our lab defers to pretty much sort of STEM-oriented things. And so that's what I'm going to be talking about today. So, what is it? Why is it important to have the right workshop? Well, you want people to be successful. And in order for that to happen, you need to know your target audience. You need to make sure that it's a safe and comfortable place. You need to know that it's sort of scalable, that material costs are manageable. Is it too technical or not technical enough for your audience? And do you have the right amount of time? And that's what I think about a lot. But then we have failed at times to think about it from the patron's perspective. And that's like, what am I going to learn as a student? And will I be successful in completing this project? Is it going to be a stressful thing to do? And am I going to be happy with the end result? And I'm going to say that, we have failed at times and we've done well at times. And here's one of our successful failures, I'll say. So one of the first things we did when we opened our space, and I've been a manager of a makerspace for about 10 years and then had an engineering club before that, and then a little robotics club even before that. But it was like, hey, let's build this ultrasonic bat detector. We put it out to the campus. It filled up immediately. However, that said, this product cost $30. So we wound up finding that we had more faculty and staff members joining or signing up than we had students. The students couldn't afford it in some cases. And then when it came to the end, the faculty and staff finished their products and the students didn't. And then also, we didn't really have the opportunity to discuss really what was going on here and how this thing worked. So success in that we filled up the workshop, but the target audience of students, we kind of failed them. So we went to simplify things. So let's try, with our, again, physics and computer science related folks, let's do something slightly simpler. Let's work on doing some CAD work and say making a 10 millimeter, box and open end wrench. This was great. It was successful. Students could do it in an hour workshop. It was scalable. We could do this small groups. We could have summer camps coming in where we get high school students doing the same project, all being successful. We could print this in a short period of time, and it wasn't that costly for us. So that was great. But it was still a little bit more simple than we wanted because we knew we had folks who had that interest in electronics. So next goal, let's simplify what we're doing and have something that is manageable, doable. And so we came up with the idea of, going to YouTube to find out what was out there, building an alternating current circuit detector. Because we found that building sensor systems engage people. They could build a tool and then use that tool to explore the world around them. So building sensors was a really, really powerful thing for a lot of students. This thing here, all parts included, was basically just $1.50. I don't know if my mouse shows up, but the battery here was $1, and the rest of the stuff here really was about 30 cents. So it's quite manageable. We have an LED, we have 3 resistors, and we have 3 transistors. And I'll sort of explain how these things work, and then we have a little antenna thing here. And so the concept is to detect AC current. And in this example here, we have AC current running through part of our system to power our computer. It goes up to the power supply, and then the output from the power supply is DC current. But because of the voltage and current flowing through here, there is what we'll call energy that leaks out through the wires. And we can detect that energy and use it to trigger our sensor. So this is how this works. We can create a sensor, we can use it, and our device should light up when it detects, when it gets near a wire like this. Here's the lineup, and this requires us making a pretty strong amplifier because we are just looking at really, really small amounts of electricity emanating from these wires. But when we line up these 3 transistors right here in a fashion, we have a 110,000, 1 million fold amplification of what comes in here. And I'll explain a little bit more about how the whole amplifier kind of thing works too, because this is what our students wanted. They wanted to understand a bit more about electronics. So we have an LED, which lights up when the AC current's detected. We have our 3 transistors, or 3 resistors. These transistor and resistor, or resistor and transistor, all work in tandem. They work in tandem like this set of dominoes right here. We have a small domino, and when we have an input from our detector, the AC current, it has the ability to knock over that first domino, which in turn knocks over a second domino, which in turn knocks over the largest domino. And this is this amplification. And in our case, we have a 1 million-fold amplification of that initial power coming out of that wire. So very high amplification. In this sense here, the important thing we need to do is we need to scale those dominoes. So here we have our first set, and we have just basically microvolts being generated to come in here, but we can size a small domino with this resistor and our transistor, which can let 100 times what the current feels. Now, when we knock over the domino, gravity is pulling down the domino. The electricity emanating from the wire is the trigger, but the gravity pulls down the domino. And in this case here, it's the battery that that is equivalent to domino. Well, the battery is equivalent to the domino being pulled over. So battery and gravity. And then we triple up this scenario. Again, current is detected here. It generates electricity because it's emanating from the wire. We have it detected here. We have a battery pushing power through here, and there's 100-fold power through here. That triggers this one, triggers this one. You have all 3 dominoes coming over, which then allows enough power to come through the system to power the LED. That's it soldered up. We have 12 soldering joints in the system. So the students have a chance to solder this together with our 12. They have 12 opportunities to solder it together. And basically what we found is that this was a system that really, really worked for us. You could try other things, but again, trial and error. We found something that was doable. It was doable in time frame. It was cost effective. Uh, People weren't too stressed. They could learn to use a soldering iron. They could get it done in an hour. And to me, the important part at the end was, were we successful? And so we would ask them at the end, did you like this? Did you feel you learned something? And the answer was yes. So, getting that feedback, but then also watching the end result. To us, the most powerful indication of success is that we saw our students showing their friends how their sensor system worked and how an amplifier kind of worked by using the analogy of dominoes, of having a small signal being powered by a battery, knocking over things in series to create a much larger signal that can light a light bulb to let us know that we have an AC current generating there. And so that is it. If you feel like you've learned maybe a tad more about how maybe an amplifier works, an AC current circuit works, let me know in the chat. And if it was a waste of time, let me know too. And with that, I have time's up right now. 10 minutes. I thank you.
Thank you so much, Dean. That was a great project to hear about. And we will be doing questions for all three lightning talks at the end of the session. So we'll be moving right along to Amber Sewell, who will be presenting game jamming in academic libraries. Really excited. So I'll send it on right along to Amber.
Excellent. Thank you all so much. I'm really excited to chat with you about game jamming in academic libraries. My name is Amber Sewell, she, her. I'm a teaching and learning librarian at the University of Nevada, Las Vegas, where I work primarily with students in their general education courses. I also do a lot of gaming events co-curricularly, and I work with faculty to incorporate fandom, pop culture, games, and play into their classrooms. To start, what is a game jam? I think these are a little more popular in public libraries, not so much academic libraries. But these are events where attendees come together to either A, create an original game based around a prompt, or B, to iterate on an existing game. So to take a game and kind of make a new version of it. These can happen with digital games. These often happen with tabletop role-playing games, but these can also involve physical games. Because this event was intended to promote the Makerspace as a resource and fun, creative place for students to go, my participants were asked to create original physical games. So these could be board games, card games, anything where they are creating the game pieces in the Makerspace. Some details of the events. I am kind of the spearhead for this, in charge of kind of keeping everything organized. I took this idea to my supervisor to do the initial one for International Games Month, which is in November 2022. My boss said, sounds great. So I took it to Darcy Del Bosque, who's the head of research, innovation, and creation, which houses the Makerspace here. I pitched it to their team and they were really enthusiastic about it. So I then paired up with our making and innovation specialist, who's kind of in charge of the day-to-day of the Makerspace, and we really collaborated on building this event together. I also tagged in our educational outreach librarian, who helped with a lot of the logistics as well as purchasing the prizes for the event. And then I worked with student employees who helped me staff the voting table where games were out for anybody who walked through the library to play and then vote on the games. I've done this twice so far. The first, as I mentioned, was November 2022, and then I did a second iteration last September. So the timeline for the event, first, as soon as possible, get the event out there where students know it's happening. Recruit participants. Fall is a very busy time for our library marketing department. So depending on all of the things they've got going on for a welcome week and other beginning of the semester events, they're the ones who kind of make sure this gets out to students via email, that it's posted online, that flyers are available. The beginning of the month is our kickoff event in the Makerspace. Students are heavily encouraged to have their Makerspace orientation completed before this meeting. This is where all of the teams gather to learn about the rules and guidelines for the events, get to know the faces of the people that can help them throughout the event. We tell them a little bit about the Makerspace and the resources available for them, and then they have time to get started with their projects. They have 3 weeks to build their game in the Makerspace, and then they have to turn them into me at the end of that 3rd week. I then take them, and then the next week is voting. So I set up a table in the lobby of the library with the games and my voting forms and ask people to stop and play for a couple of minutes and then vote. And then at the end of the month, we have our award ceremony. So just to show what this looks like, fall of 2024, we started promoting as soon as marketing was able to. Our kickoff event was September 3rd. The games were due to me on September 24th by 5 p.m. And then the next day they were out in the lobby for voting. Voting ended October 2nd. I tabulated all of the scores that evening, and then we announced the winner the next day in the Makerspace. Some required elements that I designed to facilitate this event first were the sign-up form. This was just a Google form. I asked every team to choose a communications person. So they filled out the team, gave me their team name, and listed the team members. That also gave them some key dates for the event, and then also reiterated that all members should have their Makerspace safety orientation completed before that kickoff event. I created some rules and guidelines. These included things like you must use 2 to 3 Makerspace machines. The game needs to be unmediated because this will just be put on a table for people to play. So they need to be able to have all of the materials they need for that there. Gave them the team budget. Each team gets $25 of Makerspace credit. And then it gave them details about working in the Makerspace because I didn't want to overwhelm the Makerspace if we had full capacity sign up. We allow for 5 teams of 2 to 3 people each. I didn't want to be taking up all of their resources just with this game, so I worked with that making and innovation specialist to determine some days our Makerspace doesn't open till 11, so we would have the Makerspace open 9 to 11 just for these teams. Included some game design tips. Things like make sure to include instructions, have somebody read over them first. Prototyping is really important, so make sure you take advantage of the free prototyping materials in the Makerspace before jumping into the fun machines. We did have a prototyping workshop this iteration, which I hope to improve on in the future. I create a voting form. These are just half sheets of paper I print out that have the 4 criteria, stars 1 to 5, and then circle the name of the game you played, and then prizes. So the first year, it was just a 3D printed trophy that I had made. This year, we were actually able to give our winning team tickets to Dice Tower West. So that way, if they wanted to bring their prototype and play and get feedback at that convention, they could. Participation and reception. In the November 2022 event, I had 3 participants across 2 teams. One of them was just somebody who walked in during the kickoff event because it sounded cool. They didn't even sign up. And it's a good thing they did because they won that year. Last semester, we had 6 participants across 2 teams. So our winner from the first year came back with some friends and was on the winning team again. Students really loved it. They had a great time getting to be creative outside of the classroom experience. They thought it was a lot of fun. I asked them for feedback. They definitely don't want more than 5 weeks for this project because I asked if this should be like a semester long. And they were like, no, that would distract too much from everything else going on. But we'd really like 4 weeks to build and then a 5th week to vote. They are also interested in guided next steps. So for instance, as you can see, we budgeted $25 for 5 teams. We've not hit team capacity and all of the teams have come in under budget. So we're thinking about maybe repurposing that fund to give to the winning team so they can make a more high fidelity version of their game, especially if we want to continue to give them tickets to Dice Tower West to test out their game. I've learned a lot of lessons about running game jams that I can't cover in 10 minutes, but some of the most important ones is there's always room for improvement with marketing. Students are always like, I wish I'd heard about this sooner. I wish more people had heard. Timing is super important. Turns out November's a terrible time to do a month-long event in academic libraries. Not only are people getting sick, but there are so many vacations and days off that it's hard for students to get momentum, especially with their classwork, not to mention this extra project they're doing on top of them. So avoid November. I've learned to provide more guidance than I think I need. So I forget that I am kind of immersed in the game design world. And so students in the first round, I didn't explicitly remind them about instructions. So both teams had forgotten about it and were like handwriting them 30 minutes before they had to turn the game in. So providing more structure. Coordinating again with the Makerspace about resource management, making sure I'm not overloading them with this game, but also seeing if their student workers, for instance, are interested in doing consultations with the teams about their ideas. Lastly, communicate with the students frequently, but don't always expect to get communication back. Again, this is not for a class, this is for fun, so they're not always the fastest to answer emails. Next steps, I'm going to try out a game jam in the spring. This was a recommendation from our last team. They really liked the idea of having spring break without classes to work on their games. Again, having longer sign-up time so more people can hear about it. I have not included a prompt previously because I was afraid it would constrain students too much, but the last group said that they actually think it would be really helpful for them to direct some of their focus, so to give a theme, even if it's just fantasy or space. I'd like to provide more structured support throughout, so more focused workshops that are smaller during that working time. And then my students have really encouraged me to brainstorm bigger, so partnering with our Patent and Trademark Resource Center. UNLV students are very entrepreneurial, so they want to take these big ideas. There's a lot more that goes into Game Jam, so I'm always happy to chat more and share resources, so please feel free to reach out.
Great. All right. Thank you so much, Amber. I am already just chatted a coworker about potentially doing a game jam. Love the idea. Okay, great. So we'll move right along to Monica Maselli. I hope I said your name correctly. If not, please correct me when you start your presentation. Monica will be presenting implementing maker projects outside of the Makerspace, and we will move right along.
Sure. Hi, everyone. This is Monica Michelli. I'm an associate professor at Pratt School of Information, and generally my teaching and research is around emerging technologies in the library world. I'm actually going to talk today very briefly about a couple studies. Initially, I was very interested in work that was being done with maker technologies outside of the boundaries of the makerspace. So how maker technologies were being applied to different problems in the wider library space. So this was a couple years ago. I did Zoom interviews with 12 librarians who had published information about a maker technology focused project that they had created for their library. The bulk of the projects were using Raspberry Pi and Arduino to give you a sense of the technologies. The first research question that I was exploring was how specifically these librarians had applied maker technologies in projects in wider library usage. The most popular project, and you can see a list of the top 12 or so projects on the right of the screen. The most popular project involved using Raspberry Pis to run digital signage throughout the library spaces, And there were a variety of other one-off projects, really anywhere from gate counting, patrons, temperature monitoring, OPAC terminal replacements, and other more creative ones. There was projects using a receipt printer to print poetry for patrons to raise awareness of a poetry event and week that was being hosted at the library. As part of this research, I also explored what these librarians felt would be necessary from a skills and knowledge perspective to allow a broader set of librarians to contribute to this work. And really the large takeaway from this was you don't have to have a background in IT, you don't need to be a computer scientist, you need a general exposure to scripting languages and coding, but more than anything, you need this willingness, as one participant says, to try things out, experiment, and tinker. So really accepting bumps in the road, that there may be successes and failures, and having that persistence to keep trying. So coming out of that initial research, I put together code for 5 of the most popular and accessible projects that librarians had discussed implementing in their libraries, created a GitHub library of that with the intention of making these projects more available to the wider librarian community, as well as also lower the barrier to actually implementing these in other folks' libraries if they desired. So the next phase of this project was taking the GitHub library of tutorials and code samples that we had developed and employ it in a case study, which we did at the Pratt Institute Academic Library here at Pratt. And the goal was to see how these projects would actually fare in practice, whether librarians could follow the materials to both gain inspiration about what they may want to do with their maker technologies in the wider library sphere, and also to be able to iterate and improve on the educational materials that we had developed. So we have 2 library locations at Pratt Institute, a small library and a main library. And we contacted the individual in the role of user experience librarian, and he and a few other staff members were the key contacts during this project. He chose what projects out of that list of projects in the GitHub that he would like to implement in the libraries. They did end up creating 2 digital signage platforms, as well as 2 Raspberry Pi devices that were serving as online public access catalog stations, which are typically low cost, low power computers that are placed throughout the library so patrons can easily access catalog records on site. So this was a longitudinal study in which the case study participants built the projects and ran them for about an 8-week period. And I conducted interviews with the main participant at the beginning, middle, and end of the study. And I also asked him to try to track loosely the amount of time spent and any other questions, comments, or issues that came up in a diary that was kept on Google Sheets and available to both myself as the researcher and the participant. Just to give you a sense visually of what some of these projects looked like, I'm imagining probably most folks here are familiar with the Raspberry Pi. So you see on the left the Raspberry Pi, which is a single board computer, very popular in the making world. This is actually a fairly old version of the Raspberry Pi. So we wanted to make sure the projects would be accessible for makerspaces that were not necessarily purchasing the most recent hardware. So this was the digital signage display project. As I'm sure you're familiar, digital signs rotate different information, opening hours, other information of interest in typically public spaces of the libraries. So my interviews with librarians revealed that there was a lot of usage and appreciation of the Screenly open source software, which is able to run on Raspberry Pi. So this was what the participants used. This was a smaller display screen that was run in the smaller size library. And then in the main library, there was a pretty nice setup with running a larger display screen placed near a passageway. So with a lot of foot traffic in that area. On the left of the screen, you can see the screen in place and in use. And in the right, can see zoomed in the little Raspberry Pi kind of placed on top of the screen. That's actually operating the display software. So the second project they implemented, as I said, was using the Raspberry Pi to host the library catalog website, so to serve as an OPAC kiosk in the library. This project ended up being a little rockier, and there were some performance issues with the Raspberry Pi, but just a few screenshots of this. Again, it doesn't look any different than any other public access station setup, but behind the scenes, the Raspberry Pi is running the kiosk platform. So really what I was interested in learning from both these studies, in particular the case study, is just how feasible is the use of maker technologies in the library outside of the makerspace. And generally the findings were that the projects tended to be easy to implement initially, and they could serve as low-cost, flexible alternatives to traditional library technology. They also notably gave the librarians and staff quite a bit more control over how the project was developed, where the data was going, who was in control, and you can see that opinion mirrored in the quote from the case study participant on the right there. However, as I'm sure you're all familiar with maker technologies, there's plenty of technical issues that can come up, and one of the projects, the OPAC station, was eventually abandoned because the Raspberry Pi just simply wasn't powerful enough from the hardware perspective to run the station smoothly. So coming out of that case study, we did revise educational materials based on the participants' comments, as well as diary study feedback that came up along the way during the 8-week period. So attempting to make these materials clearer and also make note of potential issues people may encounter. Oops. So just to wrap up with the practical implications here, I think there's a lot of potential for maker technologies to be moving kind of outside of the constraints of the makerspace itself. The focus of this research was really around, well, how can we use these technologies to contribute to our practical needs within library spaces? But I think another theme that emerged from talking with participants is that this also serves as a really nice opportunity to share these different technologies with people that may not necessarily be coming into the makerspace or think of themselves as someone that's interested in the makerspace. So just literally physically getting these technologies into more wider use in the library where someone could come across them also served as an advertisement in part for the makerspace itself. And then lastly, continuing on this work, as I said, we did build out the GitHub library with these popular library projects, and I'm hoping to continue to develop that and make it even more accessible to folks that perhaps don't have pre-existing experience with these technologies. So I'm just about out of time here, but you can see my contact information here, as well as a couple of the publications that came out of this research. Most recently on the case study, the publication is from the Information Technology and Libraries ITAL journal. So if you're interested in learning more about the projects or the process, there's plenty more there. All right, thank you for listening.
Okay, great. So we have a few minutes for questions. I've been monitoring the chat throughout, and we have some lovely comments just praising everyone's great work. We have one question from Atlas asking if Monica has any materials for the initial projects that let's see. We looked at the poem receipt maker. Do you have the Git? Okay, that was easy. There you go. We have that link now. And then there was a question for Amber about the turnout for events. How has your turnout been? You can either answer in the chat or should be able to unmute yourself. Oh, you are already unmuted.
Yeah, like I mentioned, we had 3 participants in 2 teams in the first iteration, and then for the one we did in the fall, it had 2 teams with 3 people each. And then for the award ceremony, which I use very loosely, it's often the team members, myself, and the making and innovation specialist, and then the head of my department and the head of the department the Makerspace is in will often show up and just kind of praise the teams for the awesome work they did, but also ask questions about how they would like future events to go.
Okay. Does your university have like a game design program or like minor or major or anything like that?
You know, I should know that. I don't believe so. No, it looks like the closest we've got is a Bachelor of Science in Entertainment Technology and Design, but nothing game design in particular.
Okay, just curious.
Yeah.
All right, I'm not seeing any more questions in the chat. So let me see, I'm put my display back on grid mode here. If you have any questions, feel free to raise your hand and you should have the option to unmute yourself at this point. So I'll give everyone a chance to do that. Or you can put them in the chat and I'm happy to read those out for you.
Hi, I had a question for Dean. Really interesting work, and it's cool you got participants soldering during the workshop. I was just curious if you had considered any of the available games or things where you kind of teach when you teach like circuit building, or whether you wanted the focus to be really something hands-on and very kind of DIY.
We wanted it to be more DIY and using um, the components that people would see like in a TV set kind of thing. A lot of times today, you use surface mount technology, so the components are the size of grains of rice. And we've done some workshops where we build FM radios doing surface mount technology. But in this case, we wanted something larger. The surface mount, you use a heat gun or a toaster oven, and you fuse components onto a circuit board. And the students really wanted to learn soldering. Again, we have folks from computer science and physics who wanted that physical process, and the bat detector was just too much. And so this was simplified, and it gave them something larger that they could play around with. And the example was something that seemed to work for us because they were very excited to like show it off after the fact kind of thing.
Cool, thanks.
Thanks for the question.
Oh, great questions. I'm gonna see if anyone else speaks up. I'd have one more for Monica. I'd love to ask, but don't want to take over. Okay, I'm gonna go for it. So Monica, I wonder if you've ever had, and maybe forgive me if you mentioned this in your presentation and I missed it, but have you ever had students or student workers or anything like that take part in these projects that happen? Because it sounded like it's mostly library staff that are doing these projects, but do you ever use it as a learning opportunity for students as well?
Yeah, I actually, so since we have, we have our Master's in Library Science program, we actually have a lot of intersection between the students that we teach and the students that are employed in our libraries, usually as graduate assistants. So I don't know that there were any that were directly hands-on when the case study was running, but part of what I did in the development of the project was have least I think 3 total students go through the projects and work on setting them up. And I specifically look for students that really had no pre-existing experience in this area. So I'll say for the most part, they were serving as testers at this stage. I do some research also on makerspace education within LIS. And I have taught before at Pratt a physical computing class and trying to start to introduce these technologies and these skill sets kind of actually within the library science program is also something that I'm interested in working further on in the future.
That's so amazing. And I know we need to end up in the session, but I'd love to chat with you more about that if you
Sure.
are interested. I'm gonna put my email in the chat. I'm also, I think my information is on the grant website, but oh, I just put my Gmail. That's not right. It's Friday. My brain is mush. Okay. All right. Well, thank you so
Perfect. Yeah.
much for from all three of our presenters. I enjoyed this very much, and we will see everyone at one of the next lightning talks and at the closing session. Take care. Bye-bye.